So now we will be dealing with the classification part of the open channel flow. So now in this lecture we will be dealing with the classification of open channel flow. Fine. Now in this classification part we will be dealing under 5 different parameters. Fine. So first one will be variation of flow parameters with respect to time. Variation of flow parameters with respect to time. There are 5 parameters. We will be dealing it one by one, but let me write all the 5 classifications which we will be encountering. So variation of flow parameters with respect to time, variation of flow parameters with respect to space. Third one is your classification based on turbulence. Fourth one is your classification based on concept of critical flow. Concept of critical flow. And the last one is your classification based on conceptualizing the flow as 1D, 2D and 3D. Fine. So I have written all the 5 types in which we can classify the open channel flow. Fine. So now we will be dealing one by one. First one is your variation of flow parameters with respect to time. So first one is your variation of flow parameters with respect to time. In this, my dear students, we will be dealing with 2 different terms. First one is your steady flow and the second one is your unsteady flow. Fine. Now, do you know the difference between the two, when the flow is steady or when the flow is said to be unsteady? Do you know the difference between the two? Come on, just tell me first. If you, then could you give me a mathematical expression for steady flow and for unsteady flow? Come on. Now, I will tell you what happens is, when we are talking regarding the flow parameters, fine, when we are dealing with classification of open channel flow, then in this I have written variation of flow parameters. So what are these flow parameters? These flow parameters which I am talking, these are your discharge, your depth of flow, your velocity. Fine, these are your discharge, depth of flow and your velocity. Now what happens when I am talking regarding the steady flow? The parameters, the flow parameters at a particular section does not varies with respect to time. I am repeating it again. The flow parameters at a particular section does not varies with respect to time, then it is the case of steady flow. Fine. So let me write it. Flow parameters at a particular section does not varies with respect to time. Now, to make this statement more clear, let me draw a diagrammatic representation. This is your channel bed. Fine. And what happens is, this is your some sort of flow. This is the pattern of the flow which is occurring. But what you see this pattern is T is equal to T1, T is equal to T2 up to Tn. At this portion, you will get the depth of flow as Y1, fine, and at this portion, you will get the depth of flow as Y2, fine. Now, what I told you is, what happens is, what I am telling that flow parameters at a particular section, like if I am talking regarding this section, so be it at any time, be it at time T1, T2 or Tn, you will get the depth of flow as Y1 at this section, fine. And when you go to this point, that is this section, you will see similarly at point T1, T2, Tn at any time, you will get the depth of flow as Y2. So, if you will be given this diagram and if you would be told nomenclating all these things, is this flow is steady? You will say yes, because at a particular section the flow parameters are constant, fine. Now, if I ask you, just tell me mathematically the expression for steady flow. So, how you will write it as mathematically del Q by del T is equal to 0, del V by del T is equal to 0 and del Y by del T is equal to 0. So, mathematically if the flow is steady, you will get it at this expression. One thing I will make you more clear is, what happens is, when I am dealing with respect to time, I am not at all talking with respect to space, that is with respect to distance. Whenever I am talking with respect to time about the variation of flow parameters, it will be distinguished into steady flow and unsteady flow. I do not have any relation with space here, that is with the distance. I am only concentrating in the time part, fine. So, this was your steady flow. Now, moving to the unsteady flow, it is just the opposite what you got in your steady flow. What is happening? Flow parameters at a particular section, in place of does not, it varies with time. So, let us write that first. Flow parameters at a particular section varies with time. Now, how does this unsteady flow can I represent? Let me draw. What happens is, if let us suppose there is a dam, fine, there is a dam and initially the flow was taking place something like this. The flow was taking place at time t is equal to t1, your depth was y1 and the flow was taking place. Now, what happened was, this dam failed. If this dam fails, what will happen? The flow will occur something like this. So, what you will be seeing that at any instant t is equal to t2, your depth of flow at any section will be obviously greater than y1, but it will not be y1 only, it will be y2 or y3, any depth, but it will not be equal to y1, fine. So, what you saw is, let me draw it more clearly, it got mashed up. You will see this was your flow and this is your flow. So, at t is equal to t1, your depth was y1, at t is equal to t2, you got some other depth as y2. Or if you will consider at this section also, at any particular section, you will not get that same depth, you will not get the same flow parameters, Fine. So, what I told you that flow parameters at a particular section it varies with time. At one particular time you are getting some other depth, some other discharge, at other time you will be getting some other depth, some other discharge. So, this happens if the dam fails. Fine. So, I will represent this also mathematically first before moving to the next one. So, mathematically what happens is del q by del t is not equal to 0, del v by del t is not equal to 0 and your del y by del t is not equal to 0. Fine. So, you will be getting this expression in the case of your unsteady flow. Just one thing I am telling you again and again, these are the variations with respect to time. Fine. So, now moving to the next variation, that is variation of flow parameters with respect to space. So, second one is your variation of flow parameters with respect to space. So, now could you tell me how do we just tell how the difference could be variation of flow parameters with respect to your space? How could you classify? Now, when you are talking variation of flow parameters with respect to space, this can be in two parts, that is uniform flow and your non-uniform flow. Now, here we do not have any relation with time, we are talking with respect to space. Fine. So, what happens in the case of uniform flow is, if the flow parameters at a particular section of channel reach does not varies with respect to space, that is with respect to the distance, then it is the case of uniform flow. So, shall I write that first? If the flow parameters at a particular section of channel reach means portion of the channel, at a particular section of channel reach does not varies with respect to space, then it is your uniform flow. Now, I will draw a diagram . Now, what you see, if the flow is taking place something like this, fine, at this section you are having the depth of flow as y1, fine. After travelling a distance x, you have the same depth of flow, as y1 only, fine. There may be some, like here y1 appears to be small, you can draw it yourself now. y1 and y1 I have written it here, that means it is same, fine. So, initially at this section your depth was y1, after travelling a certain distance the depth of flow was again your y1. So, what I told was your flow parameters at a particular section of channel reach does not varies with respect to space, that is with respect to distance, fine. So, now if I want to express it mathematically, what I can write is, mathematically I can write as del q by del x is 0, del v by del x is equal to 0 and del y by del x is equal to 0. So, this happens in the case of your uniform flow. Fine. Now, what happens is you could be given two parameters also, like you could be given del q by del t 0, del q by del t is not equal to 0, similarly del q by del x is equal to 0 and del q by del x is not equal to 0, and you will be given four options: steady, unsteady, uniform, non-uniform, and they can ask you the match the following. So, simple 1 marks questions could be framed. Similarly, now moving to the non-uniform flow, it is just the opposite of your uniform flow. If the flow parameters at a particular section of the channel reach varies with respect to space, then it will be the case of your non-uniform flow. So, if the flow parameters at a particular section of channel reach varies with respect to space, then the flow is said to be your non-uniform flow. So, now you can write it, this is simple, there is something a steep slope sort of, and the flow is taking place. What do you find that somewhere here you get the depth of flow as y1 if it flows something like this, and after covering a distance x, the flow at section this portion you will get it as y2. So, what you are seeing is after covering a certain distance, the flow parameters are not same as that of the particular section. So, mathematically if I represent it, it is del q by del x is not equal to 0, del v by del x is not equal to 0 and del y by del t is not equal to 0. So, these were the two variation of flow parameters. First one was with respect to time, second one was with respect to space. Now, in this introductory lecture, because in the coming lectures we will be proceeding to the gradually varied flow, it takes time, fine. We will be dealing with uniform flow, energy depth relationship, then gradually varied flow. So, there will be gradually varied flow, rapidly varied flow and spatially varied flow. So, what is the difference between the three? Because this is the first chapter, that is your introduction to open channel flow. I will give you the brief introduction, and regarding all the mathematical expressions to how to solve numericals, all that portion we will be dealing in that particular chapter, fine. So, now in this non-uniform flow, what happens is this non-uniform flow can be classified into three different parts. First one is your gradually varied flow, second one is your rapidly varied flow, and third one is your spatially varied flow. Fine. So, these are the three classifications in the category of non-uniform flow. So, now we will be dealing it one by one. Moving to the first one, that is your gradually varied flow. Now, what happens in the case of gradually varied flow, if the depth of flow changes gradually over a long distance along the length of the channel such that the free surface curvature is very mild, then the flow is said to be gradually varied flow. I will explain with the help of a diagram, you will understand it better. This is your channel bed. What happens is, if depth of flow varies gradually, means slowly it, like this was your depth y1, and after covering a large distance your depth was y2. So what you saw was, if depth of flow, this is varying very gradually after covering a long distance. This distance long means how much? The distance is in kilometers, like after covering 10 kilometers, 15 kilometers, there will be a gradual variation in the depth of flow, and sometimes it is not visible with the naked eye as well. Fine. So this is the case of your gradually varied flow. So I can write, if depth of flow changes gradually over a long distance, along the length of the channel, such that, I will write it here, such that the curvature of free surface is mild. Surface is mild, then the flow is said to be gradually varied flow. To be gradually varied flow. In short form we write it as GVF. So as I told you, just one thing more here, I haven't written anywhere time, I haven't mentioned anywhere time. So similarly, if depth of flow is changing with respect to distance, obviously because I told you it is the case of your non-uniform flow. So you can see your depth changes with distance, fine. So that this curvature of the free surface, this is what your free surface, because it is exposed to atmospheric pressure. So the curvature is very mild, and this distance x, basically it is in kilometers. Fine. Now moving to the second one, that is your rapidly varied flow. Second one is your rapidly varied flow. Now, what happens in the case of rapidly varied flow? Some students, what they think while they say rapidly, when I say rapidly varied flow, they think the variation is very rapid with respect to time. No, my dear student, rapid means sometimes you relate it with time, I don't know why, but you do that. So here also non-uniform flow, this terms comes into picture when we are dealing with respect to space. Fine. So here what you will see, the depth of flow changes rapidly over a short reach of the channel, or you can say a short distance of the channel. Now you will ask me, how you can say the short reach, what is the dimension, what is the value of the distance. So generally you can say the value of the distance is in meters, fine. So I can write, if the depth of flow changes rapidly over a short reach of the channel, or you can write a small distance, then the flow is said to be rapidly varied flow. Now, giving example of rapidly varied flow is, you will be starting this, you don't have to worry, just I will give you, suppose there is a sluice gate which is here. So what happens when flow occurs from the sluice gate? Initially the depth was y1, and from here the flow occurs, the variation of flow is very rapid, that is, it is the case of rapidly varied flow, and your hydraulic jump occurs, and here your depth of flow comes to be y2. This is your channel reach in a small distance of x, which is in meters. Fine. So, what you saw that this occurs under the sluice gate when there is a depth of flow initial was y1 and the flow varied, there was a case of rapidly varied flow, hydraulic jump formation occurred and you get the next depth after travelling a distance x as y2. How this came, what is the expression for calculating, what is the theory behind it, find what is the slope profile, all these queries will be solved when we will be dealing with the rapidly varied flow. Fine. So, this was your rapidly varied flow. Now, coming to the next one, that is your spatially varied flow. So, now coming to the third one, that is your spatially varied flow. This I will explain you first with the help of a diagrammatic representation, then we will write the definition of it. Fine. Now, what you see is initially the discharge through the channel was Q1. Now, what happened was some tributary came from here, fine, and you got the discharge as Q2. So, if I ask you at this section, what is the discharge? You will say that it is Q1 plus Q2. Fine. Now, the channel is moving and you see at a particular time, you have the discharge here as Q3. This discharge went out. Fine. So, what you see at this portion, if I ask you the discharge, the net discharge, you will say it as Q1 plus Q2 was the discharge, but because Q3 discharge went out, you have the net discharge as Q1 plus Q2 minus Q3. Now, I told you the diagrammatic representation, I tell you that this is the case of your spatially varied flow. Now, could you let me help to define, could you tell me how to define this? Just by looking at the figure, this is very simple, fine. I want you to be very active in the class, I want you to be interactive in the class, fine. So, now what you see is, here at some point of time, at some point of flow, sorry, it is not time, at some point you are seeing that some amount of discharge is added, while at some point while travelling a distance, you see that some amount of discharge is withdrawn or subtracted. So, whenever there is an addition or subtraction of discharge, it is the case of your spatially varied flow. Fine. So, I can write it here, addition or subtraction of discharge leads to spatially varied flow. In books, you can find it like this also. Initially, suppose this is the channel bed. So, now what is happening is, initially the flow was uniform flow, fine. Then what happened was, you got something like gradually varied flow, then you got something like rapidly varied flow, means across the steep channel sections rapidly varied flow. So, what you see it, initially it was uniform flow, then it went to gradually varied, then rapidly varied. So, you can see that there is a variation of the flow parameters with respect to space. There can be addition or subtraction of your discharge. So, this is the case of your spatially varied flow. Fine. So, we have came across all the non-uniform flow. What are the different types of non-uniform flow which can be possible? Now, I want you one thing more, that these study, unstudy uniform flow and non-uniform flow you have come across, and now you are familiar with it, I guess. Fine. So, now can I make the combination of these four? This is uniform, non-uniform, study and unstudy. Can I make the combination of it? Of course I can do, right? So, now I hope you have written this. I am erasing it off. So, now I will make the combination of it. You tell me first whether that particular combination is possible or not. Fine, you tell me. And you also try to frame an example that if particular combination is happening, then how can you represent it diagrammatically? Because what happens is, just for the sake, you don't know the pattern, what pattern gate will be asking questions. If they will give you some sort of diagrammatic representation and they will give you 4 combinations and they will ask what this diagram represents, signifies, which of the following 4. So, you should be able to answer. This happens when you are clear with the concepts. Fine. So, now let us, I will erase this first, then we will be dealing with the combination part of all the 4. Well, then you can also write the combination part. By the time I erase the board, you can also frame and you can also start to draw. Now, fine. So, now first one, let us write it as study uniform flow. So, combination of this, in this we will be doing the first one, that is your study uniform flow. Fine. So, now just the definition of both these two will make it as study uniform flow. That is, flow parameters are not varying with respect to time and flow parameters are also not varying with respect to space. So, can I write it as flow parameters does not varies with respect to time and flow parameters does not varies with respect to space. Fine. Just study flow definition you know the definition of your uniform flow, that is will be the case of your study uniform flow. Fine. Now, what you see is, let me draw the diagrammatic representation of it. In study uniform flow, like suppose this is your channel bed. First it is saying that it is not varying with respect to time. So, if this is the flow at t is equal to t1, t2, tn, your depth was y1. Now, after covering a distance of x, your depth was y1 only. Now, you will get confused. What you will say is, ma'am, when you dealt with the study flow, you told that at particular section this you had the depth of flow as y1, fine. Then at this section you had the depth as y2. Now, my dear students, if I say that I am not caring about time, I do not have any relation with time when I am dealing only with steady flow. I am only saying all the parameters variation with respect to time. So, if what happens is, here depth is y1 and at any time t1, t2, tn, I am not interested in the distance as I told you earlier. Here the depth is also y1. So, is my criteria for study flow satisfied? Of course, right, because Here the depth is y1. At this section if the depth is y1, then what is the problem? You got the depth, fine. It is constant with respect to time. So here also, if this would be the case, and I haven't mentioned the distance, this would be the case of your study flow also. So now, variation of flow parameters with respect to time, it does not varies, it is not varying with respect to space. So this is the case of your study uniform flow. Now coming to the second one, that is your study non-uniform flow. Now you tell me the definition of the study non-uniform flow. What is happening is the flow parameters are not varying with respect to time, but it varies with respect to space. So can I write it? Flow parameters does not varies with respect to time, and flow parameters varies with respect to space. Fine, is it correct? This is the case of your study non-uniform flow. Now I am drawing a diagrammatic representation for this. You tell me whether it is right or wrong. Come on. Tell me, come on. I have drawn this. You tell me, seeing this diagram, that whether it is the case of study non-uniform flow or I have drawn the wrong diagram. Come on. See it first. What you will see is that at time t1, t2, t3, tn up to tn, you are at a particular section, your depth of flow, that is the flow parameters, are constant. This portion also, at this particular section, you have the flow parameters constant. So yes, this is the case of study flow. Now moving to the distance part. It has covered x distance. Initially the depth was y1. After covering a distance x, the depth changed. That is, your flow parameters changes. That is, the flow parameters are not constant with respect to distance. So this will be a case of study non-uniform flow. Now moving to the third one, that is your unstudy uniform flow. Now before I should write, you should be able to write it and draw and tell me that ma'am whether it is right or not. Fine. Like study flow, flow parameters varies with respect to time, but flow parameters does not varies with respect to space. Fine. So let me write the definition first. Come on, till then I am writing the definition. You draw and tell me whether this case exists and is it practically possible. Come on, till then I write the definition. Flow parameters varies, flow parameters varies with respect to time. Flow parameters does not varies with respect to space. Fine. Now unstudy means flow parameters are varying with time. Uniform means the flow parameters does not varies with respect to space. Have you drawn it? Let us see. You just verify with my diagram. Flow parameters varies with respect to time. That means at time t is equal to t1, I have the depth here as y1, fine, and at any time t is equal to t2. My depth, suppose at this section only, my depth is y2. So fine, this will be the case of your unsteady flow. Now, what it is telling, flow parameters varies with respect to time, it is okay. Flow parameters does not varies with respect to space. That is, after covering a distance of x, here I should get the same depth of y1, like this depth should be y1 and this depth of flow should be y2. Is it possible? Come on, look at this and tell me. Flow parameters varies with respect to time, fine, it is okay. T is equal to T1 you are getting at this section because it is told at a particular section, at a portion of the channel. So, at this section your depth was y1, at T is equal to time T2 your depth was y2 at the same channel section. So, fine, this is the case of your unsteady flow. Now, coming to the uniform flow, after covering a distance x, you should get a depth y1, fine, and at time t is equal to t2 you should get the depth as y2. Is it possible? Practically also you can see this is not possible, fine. How could you say that the flow is unsteady but the flow is uniform? You try to draw the diagram, some people what they do? They do it as here also they will get y1 the same depth and here also get y2 at the same depth. But it doesn't happen because when you understand the meaning, you can yourself draw the diagrammatic representation, and if you see this condition of unsteady uniform flow is practically not possible. Fine. So, this case is practically not possible. Fine. Now, moving to the last one, that is your unsteady non-uniform flow. So, the fourth one is your unsteady non-uniform flow. So, here what you can see, the flow parameters varies with respect to time and it varies with respect to space as well. So, I can write flow parameters varies with respect to time and flow parameters varies with respect to space. Fine. This is the case of your unsteady non-uniform flow. Now, how can I represent it? Something like this, if your dam is there and if the dam fails, so what will happen is, this will be something at time t is equal to t1, this will be a profile, somewhat here will be a profile at time t is equal to t2. So, what you will see it, unsteady flow is also there and the variation happens due to the distance as well at t is equal to t3. Fine. So, this is the case of your unsteady non-uniform flow. Fine. You can also draw it like this also. Initially t is equal to t1, you have the depth as y1, something like this, t is equal to t2. Fine. This happens just the reverse basically if the dam fails. I will draw it. Initially it was here, this is moving, this is your dam. Fine. Then it starts to move something like this. So, what happens is, if you will see the distance x, initially if some distance here was y2, then you will get a distance of y2 dash. At time t is equal to t1, at time t is equal to t2. Fine. You can see here also, if you are getting initially as y1, then you will get it at this section as y1 dash. It doesn't varies, it varies with respect to time, and it varies with respect to space as well. Initially y1, at different time it has the different depth. Similarly, it doesn't have the same depth of flow with respect to distance as well. So you can frame yourself the diagrammatic representation provided you are clear with the concepts. So here we completed the two classification of open channel flow, that is variation of flow parameters with respect to time, and second one is your variation of flow parameters with respect to space. So just in a brief form of summarizing it, can I write it as like classification of open channel flow in this? One part is your study, other part is your unstudy. In study you have two parts. One is your uniform flow, and the second you have three parts. This one. In this you have three parts. Basically, gradually varied flow, rapidly varied flow. In short, we write it as RVF, and spatially varied flow, that is SVF. Spatially varied flow. Here I am writing, after this, whenever I am writing SVF, that is spatially varied flow, and this is your rapidly varied flow. Fine. Similarly for unstudy you don't have any case of uniform. I told you already, like unstudy uniform flow is practically doesn't exist. So in unstudy flow you have gradually varied unstudy flow, gradually varied unsteady flow. In short form you write it as GVUF. Fine. Similarly you have rapidly varied unsteady flow, RVUF, and last one is your spatially varied unsteady flow. That is your SVUF. Fine. So in unstudy you have all these three. In study you divided it into uniform and non-uniform flow. We have these three parts. Fine. So this was your classification of open channel flow, which I summarized based on your variation of flow parameters with respect to time and with respect to distance as well. Fine. So now I hope these two are very much clear to you. In the next session we will be moving to the upcoming all these three. Till then you please be familiar with these terms, fine, and you try to understand this diagrammatic representation, draw yourself also, fine. So we will be moving to the next lecture. Thank you.